So welcome in my part 3 of presentation. Still a continuation of the data presentation. So we highlighted the two categories of data presentation, that is tabular form and a graphical form. So now I'm tackling the tabular presentation part of the data. And now that I was to be tackling two categories, that is frequency distribution and contingency table. But being the topic is so wide, all of this I've just covered frequency table. Maybe in my next presentation I'm going to cover now contingency table. Is when we move to the graphical method, part of the presentation of the data, the category 2. So this is specifically frequency distribution table. So maybe in my presentation of part 4, now I'm going to talk about contingency table. Then I'll talk about now the graphical representation of data. Now as I start, let me start by defining what is a tabular presentation, or presenting data in form of a table form. So let's define. Now tabular presentation involves organizing data into rows and columns to make it easier to understand, compare, and analyze. It involves organizing data into rows and columns to make it easier to understand, compare, and analyze. Or in a nutshell, or in a simple explanation, just organizing data into row and column, into a table form. You see, a table must have a row and must have a column. For example, this might be my table. I have the column and I have the rows. So these tables have how many rows? 1, 2, 3, 4, 5 rows and 2 columns. So when this data is organized into this form, we call it a contingency table or a tabular form. But this was meant for specifically frequency distribution. So we'll do one for the contingency table after I finish this one. Now the categories are for the tabular presentation to a frequency distribution table, which does what I've done, and the second part is the contingency table, which I'm yet to cover. Now let's start with the frequency distribution table definition. So with the frequency distribution table, it shows how often each value occurs in a database. How often a value occurs in a database. For example, I want to select maybe the student for a trip, to play a match. Then the number which I need must be based on what? Maybe the age limit. For example, I might say I'm having 50 students, but there are categories, say maybe from 17, age 17, 19, 20, 30, even. So I may say all of the group of students the same. Now the one with 17 years of age, asonge huko. The other one with 18 years of age, so utapata the one with 17, maybe around 10, wamenda the first on the other side. The one with the 18 years, maybe there may be 2. The one with the 19 may be 4. So when we present that, when we show that in the table where each value occurs in the data set, then we call it what? A frequency distribution table. Now steps involved in construction of frequency distribution table. Number one step is identify the number of classes. So you must identify the number of classes before you construct your frequency distribution table. So how do you identify the number of classes? Now, in identifying the number of classes, that is a task only left for the learner. That you have to identify the number of desired class. So each and every one you must identify the number of desired class. For example, this is what we call it a class. Let me change here from grouping to class. Now this is the class. For example, with your data, you want how many? So these are how many classes? 1, 2, 3, 4, 5 classes. So let's say you identify the number of desired classes. Now that is independently to the learner. So I'll teach you how to identify those classes. Number 2, find out the class interval. Now when we say find out the class interval, now this is what we call a class interval. Go with me. You see, we have 0 to 5. That's an interval between 0 to 5. Then we have 5 to 10. There's an interval between 5 to 10. Then 10 to 15, there's an interval between 10 to 15, then 15 to 20, and finally 20 to 25. So we talk about finding out the class interval. So that's the interval. Now, in most of the questions, we'll be given already existing interval. For example, in this question, if we read it, we have been given these values, and we are taking a class interval as 5, construct a frequency distribution table. So already we have been given an interval of 5. For example, same as 0 to 5, that is 0, so we will sample 0 to 5, that's 0, 1, 2, 3, 4, and 5. No, 0. Actually, for this case, we trace the number between 0 to 5. That is 0, 1, 2, 3, and 4. It's up for 5. Same 5 to 10, another from 5. That's 5, 6, 7, 8, and 9. They are 5. Are we together? So that's what we call a class interval. Now, when you're in a scenario you're not given a class interval, then there's a way you can calculate a class interval. And this is the formula of calculating class interval. I've shortened it and abbreviated to CI, meaning class interval. So class interval, you will take a maximum value, you subtract a minimum value, then you divide by the desired number of classes that you are decided to have. That will give you your class interval. You take a maximum value, you subtract a minimum value, then you divide by what? The desired number of classes. In a scenario, in a question, you are not given a class interval. So that's how you get your class interval. Then step number 3, choose the class limit which is uniform. Now your class limit. I'll explain it to Kifanya when we'll be drawing frequency distribution table. My next subtopic, I'll go to what? Types of series. Now, before you construct a frequency distribution table, you must understand the series in the frequency distribution. It is a very, very fine and important element. If you don't understand it better, then it will be very difficult for you to construct the table. So, how many types of series do we have? We have 3 types of series. So, we have individual series, we have discrete series, and we have continuous series. We are really going to need this while we'll be doing a topic of measure of central tendency. So, you'll understand which type of data are we dealing with. Is it an individual data? Let me say it maybe individual series stroke data, discrete series stroke data, and continuous series stroke data. Continuous series stroke data. So as I proceed now, let's define each and every of them so that you can understand it. Now, individual series stroke data. What's an individual series? Now, individual series is a type of data this is a type of data presentation where each item or observation is listed separately without any grouping or frequency. Underline separately without any grouping or frequency. So this is a type of data presentation where each item or observation is listed separately or without any grouping or frequency. For example, now let's say I'm in a class. Then we did maybe a continuous assessment test. Now I want to highlight the marks of my students. So I'll just highlight what are the marks. Tukona mwenye kuna 45, 50, 52, 48, and 60. So these are what we call individual data. Individual series or data. Individual series or data. So the venye, hizo data ziko, there's marks alone. There's no number including the number of students, just the marks. There were 45, there were 50, there were 52, there were 48, there were 60. We highlight them or list them separately without any grouping or frequency. Now this is what we call an individual series or individual data. Number 2 is discrete series or discrete data. Number 2, this is number 1. Number 2 will be discrete series or data. Now with the discrete series, this series represents data where the variables takes only specific value and each value is assorted with a frequency. In discrete series, it presents data where the variables takes only specific value and each value is associated with a frequency. Now what am I saying? Now from the individual series to discrete series, now with the discrete, now we have the individual part of the data, but it's now associated with what? Frequency. With the individual, it was only individual data, there was no association. It was listed separately without any grouping or frequency. But now, in discrete, now there must be an individual data, but it must be associated with what? Frequency. For example, we can say, let me use the same example. Yeah, let's say this here is 45, so that you understand it better. Here is 50, here's 52, here's 48, and another column and row, 48, and here is 60, 81. So assume that's our data. So in my class, I am having students and they'll start for an examination. So I've said, now 45, meaning 3 students scored 45%. So in that test or in that examination, 3 students scored what? 45. So we have the part of the division in marks and what? Associated with the frequency. Then you can also say 50, those who scored 51, 5. So 5 students scored 50%. Then here, 2 students scored 52%. 4 students scored 40% and 1 student scored what? 60%. Now this is what we call discrete series. It is only individual data or marks with what? With a frequency. They must be associated with what? A frequency. Then finally, I'll go to continuous series. Now, with continuous series, now this series represent data, grouped into class interval along with corresponding frequency. Now here, the data must have an interval. Now between this interval to that interval, between this interval to that interval, between this interval and that interval. So there must be an interval. Now what separates a continuous series in a discrete series that with discrete series, it is having an individual data with frequency. But with continuous now, it is what? The data must be interval with what? Frequency. So where you see a data having an interval, know that that is a continuous series. Where you see a data has frequency but no interval, that is a discrete series. Then where you see that individual data, that will be individual series. This element will be very, very much important when we will be covering the part of measure of central tendency. So we will now have to calculate mean, median, and mode. We'll have to calculate the mean, median, and mode for individual series, for discrete series, and continuous series. And each of them will be having a different formula. So the formula will be based on what? The series. So you must understand what is the series. So with continuous, now there must be what? An interval. For example, marks. Now, tutasema, now between 0 to 10 marks we had what? 4 students. Then between 10 to 20, when you say between 0 to 10, meaning there was a student who had 5, another one had 7, another one had 9, another one had 10. So we group them between 0 to, so those who had between 0 to 10, either you had 1, you had 0 to 5. Now we say this is an interval. So that interval covers others. Now between 0 to 10 we have 4 students. Between 10 to 20 we have 6, meaning between the 20 there was a student who had 11, who had 15, who had 17, who scored 19, who scored 20. So there are 6. Then between 20 and 30 there are 9, meaning that some scored 20 something, some scored 28, others scored 30, others scored 20 or 20, but it can't go below 20. Then between 30 to 40 you have 15 students. So those who score the marks 31 to 40. So that is now, that's the difference between continuous, discrete, and individual data. This one had interval, this one has no interval, but have frequency, but this one have no frequency. When you understand that one, then the part of the statistics or measure of dispersion or central tendency is not going to be a problem. So kindly take this into note, because we are going to apply this skill in the next 2 topics we are going to do, the mathematical part of this one. So kindly take this serious. Now I'll solve one example and draw a frequency distribution table, and that will mark the end of this presentation on the part of the frequency distribution. Now this is my example. We are given these values. You have 2, 4, 3, 1, 5, 7, 9, 21, 13, 15, 18, 17, 14, 10, 12, 16, 7, 6, 19, 22, 11, 23, 22, 24, 2, 5, 3, 4, 3, 2, then full stop. Then from there, what's the question? The question is, taking a class interval as 5, construct a frequency distribution table. Taking a class interval as 5, construct a frequency distribution table. Now we have to construct a frequency distribution table. Now before we construct, we'll check our values. Tuangalie which one is the least value tuko nayo. So ukiangalia this value, the least value tuko nayo, we have 1. Or the minimum value we are having is 1. Then the maximum value we'll be having is what? 24. Yeah. So the maximum value we'll be having is 24. So in this area, if you are told to get a class interval if the question you are not given a class interval, now we will apply this formula. Maximum minus minimum divided by the desired number of what? Class. So what's our maximum value? 24. What's our minimum value? So that should be what? 24 minus 1 divided by what? What's the desired number of class? 1, 2, 3, 4, 5. So here the desired number of class was what? 5. Then you get your class interval. So let's do it. This will be 23. They divide by 5. If we divide 23 by 5, that will be it will be, I think, 4 point something. When you round it off, you can get 5. So you can take the maximum value minus the minimum value divided by the desired number of classes. How here the desired number of classes are, we have 1, 2, 3, 4, 5. That's why I've divided by 5 classes. So that will give you interval. In a scenario where the interval is not given in the question, so note that below. Now, I've identified my minimum value, then I've identified my maximum value. Now I want to construct my frequency distribution table. So now this is what we are going to do. Now we are going to gauge, I want to get the class. Now tumeambiwa the class is 5. There's something I've forgotten. We have two methods of constructing this table. We have inclusive method and exclusive method. This is an exclusive method. I think I'm teaching inclusive method in my next presentation. This exclusive method, there's a part called inclusive method. I teach you how to draw using inclusive method. So with the exclusive method, now the class, our minimum value is 1. The maximum is 20. So we'll make sure our class interval will tackle 5. For example, now this is purely exclusive method. Now this is if our smallest value is 1. Now we are not with exclusive, we are not including everything. With inclusive method, we include everything. That's the difference. With exclusive, we are not going to tackle each and every this part, but we bring that interval between these. So I'll show you how to pick them. But with inclusive, if the minimum is 1, upper to 1, we'll start with the 1. And we must end with what? 25. Because we must include each and every number here. But with exclusive, we don't have to include everyone or each and every number. That's the difference between inclusive method and exclusive. Just from the normal term exclusive, you can exclude. Inclusive, you must include. Now, with the exclusive method, now we'll start with 0 to 5. So tumeambiwa our class interval is 5. So with the exclusive method, we'll pick the value between 0 and 5. In fact, I can do the inclusive hapa chini so that we understand it concurrently. I know I'll squeeze it, but please try to understand. Class, time column, so that we go together. And here is frequency. Let me do it this way. So the one is inclusive, the other one is what? Exclusive. So with the inclusive, now here, our cluster will begin with what? 1 to 5. Then with the exclusive, we'll start with what? 0 to 5. Now this is the analogy. Now with the inclusive, we'll count everything from 1 to what? To 5. With the exclusive, we'll count from 0, the value between 0 to 5, that is 1 to what? 4. Hope you are getting the difference. So, now, I want us to do the first column, 0 to 5 and 1 to 5. Now, with the exclusive, we count the value between 0 to 4. That is 1, 2, 3, and 4. We don't count 5. Then, with the inclusive, we count 1 to 5. So 1, 2, 3, 4, 5. We don't get now the interval between. So get the difference. With the exclusive, it is 0 to 5. That is, now we count value 1, 2, 3, and 4. With the inclusive, we count 1 to 5. 1, 2, 3, 4, and 5. Now for my value, let's go back to my value. You can zoom a little bit. Now it is 0 to 5. No, so with the exclusive, I've said 0 to 5. We'll count the value between 0 and 5, that is 1 to 4. So we'll get how many value fall between 0 to 5. So how many 1 do we have? Tuko na 1, we have 2, we have 4, we have 3. We don't count 5 in exclusive. We have another 4, we have 3, we will pass that 5, we have 2, 6, no, we have 2 and we have 3. So we only count value between 1 and 4. Between 0 to 4, that is 1 and 4. Because 0 is not a number, 0 is a cipher, so we can't count 0. Now let's count them. How many values do we have? We have 1, that's 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we only counted 1 to 4. We didn't touch 5. So there are how many values? They have here 1, 2, 3, 4, 5, 6, 7. The ones that had a mark on top of them. Hope you can see. So we have value 1, we have value 3, we have value 4, we have value 2, we have value 4 again, value 3, value 2, value 3, and value 2. So when you count them, that will be 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Then we come to my part of the tally column. Now to Besabu there are 9. So tutakuja to indicate them. We have 1, or my pen, just a minute. Now that will be 1, 2, 3, 4. So that's how we represent tally column by 5, 5. So that will be 1, 2, 3, 4. When we reach the 4, before to figure 5, we cross. That will be 1, 2, 3, 4, 5. So we have 9. So the first step will be 1, 2, 3, 4, 5, remaining 4. 1, 2, 3, 4. So we write the frequency is what? 9. Hope you've understood how to represent in the part of the tally column that value 9. So we start with 1, 2, 3, 4, 5, 1, 2, 3, 4. Now let's go to inclusive method. Now with inclusive, let me erase these ones. Now with inclusive, now we are going to count everything from 1 and 5. We are not going to get any value between 1 and 5. We are going to count 1 to 5. So we come back here again, now we mark them. Now we're going to mark both 1 and 5, but here we're only marking the value between 0 to 5, that is 1 to 4. So get the difference. So with inclusive now it will be, now we have 1, 3, we have 4, we have 2, we have 5 itself, we have 4, we have 3, we have still 5, we have 2, then we have 2, and we have 3. Now let's count them. That will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you see now with exclusive the values were 9. Now with inclusive they are 11. So we come here, we write 11. Then under tally column we'll draw it. Now 1, 2, 3, 4, 5. That's the first 5. The second 5. 1, 2, 3, 4, 5. Then 1 because they are 11. So see the difference. With the exclusive now our frequency is 9. With the inclusive our frequency is what? 11. Let me delete also this. So with the exclusive now, because we didn't count the value number 5 during when we were counting our values, so we'll start with what? Now in the lower part we'll start with the 5. Now it will be now 5 to 10. 5 to 10. So. But with the inclusive, now we are not going to start with the 5. Now we are going to start the next value. That will be, after 5, that will be now 6. So that will be 6, 7, 8, 9, 10. So that will be 6 to 10. Now get the difference here. Here, the value that ends here is what is the value that starts here. But here, tukianza na 5, tuanza na next, tuanza na 6. Get the difference. Here is 0 to 5, meaning we will start with value 1 to 4. So when we start our next class, we will start with this value, now 5. But with the inclusive, now to answer now 1 to 5, we have counted everything. So the next value will be what? 6. That will be 6 to 10. Get the difference. And let's go back again. Let me erase these ones. Hope you follow me. Now, another thing to note, now while counting these values for exclusive, remember we counted 1 to 4, we did count 5. Now for the next column, now we are going to count now from now 5 to 9. We are not going to count value 10. So we're going to count now here, we're going to count 5. So we're going to count 5, 6, 7, 8, and 9, but we won't count 10. But with inclusive, we'll count both 6 and 10. That will be 6, 7, 8, 9, and 10. Here we will count 10 and 6. Here we'll only count 5 to 9. We won't count 10. Now let's count. We start with exclusive. So it's 5 to 10. So we start with 5. And we have 5 to 10. We have meaning 7. We have 9. There's another one. So we won't count 10. So we leave 10. There's 7 here. So we'll count 7. There's 6 here. We'll count 6. There's also another 5 here. We'll count 5. So let's count them. How many are they? So we have 1, 2, 3, 4, 5, 6. So here frequency we indicate 6. Then let me read all of them that you follow. So in our frequency we have counted them, they are 6. So we come here to tally column, we indicate 6. Now 6 will be 1, 2, 3, 4, 5. Then the 6th one remains. Then let's go back to now the part of inclusive method. So the inclusive method will count everything 6 to 10. So that will be what? So another thing to make, now because we had counted 5 under inclusive method, now the lower part of the lower class is not going to count 5. So we'll start from 6. So we'll ignore 5 here now. So we'll have 7, we have 9, we have 10 itself. We also have, no, there's no any other one. So that will be what? We'll be having 7, 9, 10, 7, and 6. So that will be 1, 2, 3, 4, and 5. So here will be 5. So here we write 5. Then will be 1, 2, 3, 4, 5. Hope you're following. 1, 2, 3, 4, 5. Now will be 5. So here is 6, here is 5. The next, so our next step will be from 10 to 15. Yeah, the one next will be from 11 to 15. Hope you're seeing the difference. So 10 to 15, we're going to count value now from 10 to 14. We won't count 15. So we come back again. Let me erase this. I want to do them concurrently so that you understand both of them, both inclusive and exclusive. Now, 10 to 15, we count 10 to 14 for exclusive. So we have 10 here, 1, and we have 14, we have 13, we have 11, I think only those, 10, 14, 13, 15, no, 11, 10, 11, 13, 14, and 10. There's a 15 here. But we won't count 14, we'll count from 10 to 14. Now that's 10 to 14, 15, we'll count in the lower part, the lower class. So that will be 1, 2, 3, 4. So here will be 4. And here will be 1, 2, 3, 4. So because I have a 5, we won't cross it. Then we come back to now 11 to 15 here. Here we'll count everything. We'll count everything. So that is, we'll count 11, we have 11. We have 13. We have 15 itself, we have 14. We have another one. 11 to 15. 16, 19, 11 years. 14, 15. 13. So there are also 4. 11, yes, 14, 15, 13. There are 4. So here will also be 4. Now will be 1, 2, 3, 4. The next will be what? Here will be 15 to 20, This one will be 6, 2, 3, 4. Yeah, 1, 2, 3, 4. Here will be 4, so that will be 1, 2, 3, 4. Now with the inclusive, we count from 16, 20, everything. That will be 18, 17. This is 19. I think there are 5. I forgot 19. This is 5. It's supposed to be 19. So we'll count 18, 17, 19, 16. So there's no 20, so here will be 4. 4. Then lastly we'll be having 20 to 25. Here will be 21 to 25. 25. So let's count again. So with exclusive we'll count out 20 to 24. We want to count 25. So let's check it. Now we'll have 24, 22, 23, 22. 15, so we have 24, 22, 23, 22. There's no 20, so that will be 1, 2, 3, 4. So here will be 4. Here 1, 2, 3, 4. Then last one, 21, 25, that will be, let's count 24, 22, 23, 22. There's no any other one.
21.
There's 21. 19, 22, 23, 22, 24. Oh, there's 21. So here they're supposed to be, because 19 to 20. So these are 21. So this will be 5. And this one will be 21 too. So they are both supposed to be 5. So these are going to be 5. Yeah, there's 21 that I forgot. There's 21, 22, 23, 22, and 24. When you count them, they are 5. So here will also be 5. So that will be 1, 2, 3, 4, and 5. And that's make my representation on frequency distribution table, both exclusive and inclusive method. And that will mark the end of my part 3 presentation. We meet in my part 4 presentation, where I'm going to take you through the contingency table. Then part 5, we are going to take you through graphical methods. I'm a graphical construction. Thank you.